That's the best I can do on the screen right now. Okay, anything you want to go back over? That final exam coming up Wednesday, right?
Yeah.
Yeah. And so we're about wrapping this up, guys. So anything y'all want to look back at before the final exam? Of course, all 4 tests are up there and ready to be retaken. You can take that as many times as you want to, right? Final exam is, what, 20% of your grade? So that's 2 letter grades. Y'all understand that. On a 100% scale, final is 2 letter grades. If you make 100 on it. So every question that's on the final you've seen before, right? Understand that. All the final is just questions off the 4 tests during the term. So y'all okay? Nothing y'all want to go back over? We okay? Y'all think y'all okay? Okay, guys, we're in lab and circuits. We do like y'all to be able to develop a math formula and stuff like that. So what this is, De Morgan's theorem basically deals with, so it comes up here and tells you the wire per circuit, then you come up with a truth table. And then what I've done is I've reduced the circuit down. And then what you're supposed to see is this circuit, which is what type of gate? Not B, not B, and not C. That's not exclusive. Exclusive always has 2 inputs. An exclusive gate. I'm not going to say that. So if I was to draw this symbol right here, what would it come up and be? You're exactly right. So this is a NOR. This would be a NOR gate. This is the complement of a NOR, right? This says all lows to get a high, so any high would get a low. So what we're going to do is we take this circuit right here, which is what the engineer figured in his or her head. This is what they saw in their head. Then they developed a math equation for it. You understand that? And then they saw it reduce down. So what I've done is I've taken 3 gates and I've replaced it with 1. And what we'll find out is it's going to give us the exact same truth table. Now notice over here, what we realize is that A has nothing to do with the output of the logic. Nothing to do with it. Has nothing to do with whether the output is high or the output is low. So notice the A term down here is what? Is gone. So you'll be flipping a switch over here. You still need to flip it for your truth table, right? You understand? But there's not going to be anything connected to it. Here's a circuit right here, required 1, 2, 3, 4 gates, right? For the ABC input. Ooh, where's the reduction? Oh, it says skip the circuit. Yeah, I'll take it. This is lab A. Lab 9 is skip, and then so 8 and 10. So 10 is exclusive ORs. Huh? Nobody's done 8. Nobody's done 8. What are you saying, bro?
That's what I was checking to make sure what we did or not.
No, we hadn't done it, not even in class. Huh? Yeah, these are labs. What we're doing is going back and picking up the labs. And I don't know what lab you're on, right? You understand? Whatever lab you're on your basic gates, that's the one you should finish up first, right? So that's probably the way your trainer's already hooked up, hopefully.
All right. So we're going over lab 8 now. Do we do lab 8 or?
We need to try to do lab 8. So what you need to do, if you've got a lab hooked up on your trainer right now, what do you need to do? You need to finish that lab, and it should be in the not to be graded box up here, right? If y'all, hopefully y'all didn't take them home. If you haven't started on them, then they should be over here on top of this card over here. Okay. Are we okay? So there's only really one, looks like there's only one circuit in lab 8 that two circuits. Because took up this circuit, and then of course, hook up the next circuit, which would be nothing but a NOR gate, and make sure it has the same truth table. And what we're trying to do is just show you the power of Boolean algebra, right? You understand, where you can take a big circuit that you see in your head, and that's what a lot of people do. They'll say, well, I'm looking at this, and looking at this, and looking at this, and they'll come up with a circuit. And then they develop a math equation for a Boolean math equation for the circuit and see if it'll reduce. If it don't reduce, then what you got is the basic circuit, right? You understand? If it does reduce, then what you're doing is you're saving integrated circuits, which means either you're going to make more. You got this engineer over on this side that didn't reduce it. You're over here, you reduced it. Yours operates faster because you're not going through so many propagation delays, right? You understand? And either you can sell yours cheaper, right? You understand? Or you can sell yours for the same price and make more money on every one that you sell. So yeah, it's really neat that you can do that. So that's 8, and then 9. I'm sorry, in 10. This is exclusive ORs and exclusive NORs. Loads. Now we don't have an exclusive OR gate. We're going to use a 7486, which is an exclusive OR gate, but then we're going to simulate an exclusive NOR by inverting the output with 7404. That makes sense? So you'll get the same truth table. It's just that it prevented it. So we got the 7486 with 7404. So you're going to start off with the exclusive OR gate. Exclusive NOR gate. There's the Boolean equation. It says if both inputs are low or if both inputs are high, then Y would be, the output would be 1, right? But y'all don't pay any attention to all this blue. This is where I marked out, where y'all hook up all the trainer stuff. We're going to just hook up the inputs to the logic switches, right? You understand, and the output up to the LEDs. We're going to skip these. Then we're going to go to a comparator. This is a pretty complicated circuit, but this is kind of simulating what a 7485 does, which is a digital comparator. This is a 4-bit digital comparator. So this input they're calling A, this input they're calling B. If they're not equal, then this output should be, we'll have to see what it is. So what's these guys say? What do we say about these guys? Yeah, but what do we say about this? If the inputs are, so this guy shows you what you get when they are not equal, right? You understand? So if the inputs are not equal, you get a low. That means if the inputs are equal, you're going to get a what? A high. So that means if the A input, if A0 matches B0, then this output right here will be high. And this guy's looking for what? All highs to get a high. Yeah, this guy's looking for all highs to get a high. Right? You understand that? So it means if A and B, if the 4-bit, if this nibble right here is equal to this nibble right here, the output will be high. If they're not equal, the output will be low, right? You understand that? So that's what they're doing. So what should you expect? You should expect a what right here? Are they equal? Is A equal to B? Yeah, that's obvious. It's not equal, right? You understand? This is equal to 0. This is equal to 2. The output will be low. Huh? It's the whole nibble, yeah. So what this is, it's a lot like the 7485, which is a 4-bit binary comparator. It compares an A 4 bits over to B 4 bits. So this guy's looking at A0 and B0. If A0 and B0 are equal, then this output will be a 1. But if A1 and B1 are not equal, this output will be a 0, and this guy right here is going to stay at a 0, right? You understand? The only thing about the 7485 is it adds additional circuitry to tell you which one is greater. So the 7485 says A is equal to B. When we say A is equal to B, I'm talking about the whole nibble, right? You understand? And then the 7485 also says if they're not equal, it tells you if A is greater than B or B is greater than A. So right here, what would we get out? What should we expect out? Should expect a 0 out because they are not equal, right? What should we expect here? 0. What should we expect here? A 1 because they're what? They're equal. What should we expect here? 0, 1, 0. That makes sense. So this is a comparator. This is a 4-bit binary comparator. And the 7485 gives you 3 outputs where you can feed it into the next 7485 where you can actually combine these. So you can use 2 7485s to get a 8-bit comparator. But it takes 2 of them. And then we're going to come over here and we're going to get an exclusive OR, but I don't have an exclusive OR. So what are you going to have to do to the output? Invert it, yeah. So they don't show y'all this. They take for granted you know this, right? And that's it on that one. Oh, I'm sorry, 7 too. Good gracious. What I'm going to do is I'm going to drop 7 because it's all Boolean equations. So this shows you all this stuff. Then we come in. It gives you a circuit you're going to wire up or you're supposed to connect up. And then we come down here and I reduce it down for you. But this guy here has several circuits in here. So here's another circuit we'd wire up. Then I do what for you? Reduce it, you know. And then there's so I think 8 would show you enough. It's only one circuit in lab 8 and it shows you the reduction. So let's just don't worry about lab 7. Okay? And what we'll look and see, once we get this, we'll figure out what I need to do for the labs. Like I said, if you look at your grade book, then you should see all the labs. I think I got some of my desks in there. I'm not sure if I entered them or not. I did. On topic quizzes, Milton, you hadn't done 10 and 12. Jackson's not here. Tariq, you haven't done 6, you haven't done 10, and you haven't done 12. And you're in the process of retaking 5. So you hadn't submitted that or went back to try to get a bigger grade. Brian, you haven't done 10 and 12. Brian, you haven't done 12. Michael, you've done all yours, but some of you might want to go back and redo to get a what? Get a grade. Damon, you hadn't done 10 and 12. Kevin, you've done all yours, but you might want to go back and look at some of them to try to get a better grade on your topic quiz. I think topic quizzes and homework that's all part of your assignments and everything. And that's like 15% of your grade. So that's a letter and a half, right? You understand that if you made 100 on all of them, which nobody has. Remember, assignment PT4 is due before you start the file, right? You understand? Also, all y'all did the evaluation. Thank y'all. That was all you do for test 4, so that grade is already in there also. So PT4, that'll be the final assignment. Okay, any questions? Yes, no? All right, guys. Let's go to lab. 2, yeah. And why we do that is after a while you're memorizing. You're not understanding the theory. You're memorizing answers. You know. So go back and check and see which ones you got attempts left on. I don't know which ones you got.